Today we're going to learn about hash tables. Similar to stacks and queues, hash tables represent a dynamic set of data. Hash tables support insert, delete, and search operations. Where hash tables really shine is search, as they have an average search time of big O of 1, although this degrades to big O of n in the worst case. I'll start by noting that the term hash table is sometimes used interchangeably with dictionary. Dictionaries represent a generic way to map keys to values. Hash tables are a specific way to implement a dictionary using a hashing function. You've probably seen or worked with dictionaries or hash tables if you've done basic programming. Here's Python code showing dictionary usage. Let's talk about our key value mapping implementation. To do this, we'll start by exploring a similar concept to hash tables called direct access tables. With direct access tables, we have a universe of keys shown on the left. Some of the keys are in use and they point to data. With direct access tables, insert, delete, and search are all constant time operations. In other words, a direct access table is an array. And if you need to represent every key in the universe, we say U is unbounded and impractical to store in memory. Enter hash tables. With hash tables, the space requirement is big O of k, where k is the number of keys. To achieve this, we introduce a hash function that maps keys to a location in the table that holds data. Because our universe of keys is no longer unbounded, it's possible that hashing two different keys may result in the same value, called a collision. One method to accommodate collisions is called chaining. To support chaining, we introduce linked lists, and our table locations become a bucket of values. To keep search as close as possible to big O of 1, we need a hash function that maximizes randomness and produces the least amount of collisions. Here are some examples of hash functions. We won't explore these at length, but let's take a look at hashing by division. Using division, our hash function is the following. H of k equals k mod m, where m is the size of the table. Let's say we have a hash table of size 13. If the key is 50, then h of k equals 50 mod 13, which equals 11. Take a look at the GitHub link in the description for code samples. I also linked an article that shows how to build hash tables with other primitive data structures. Thank you for watching. I hope this video helps you on your computer science journey. Please like and subscribe.